So, the UAE just unveiled the largest AI chip ever built, 4 trillion transistors. Meanwhile, China has over 140 humanoid robotics companies actively deploying robots into factories, logistics centers, and public services, backed by roughly $26 billion in government funding. These two things might seem unrelated. They're not. AI is no longer just software. It's about who controls the most powerful hardware and who can put intelligent machines to work in the real world. And these two developments show exactly where the next global tech power shift is heading. At the World Government Summit in 2026, the UAE unveiled a new AI processor developed in partnership with G42 and Cerebras systems. This chip contains 4 trillion transistors and is positioned as the world's largest AI accelerator. To put that in perspective, most high-end GPUs today have between 50 and 100 billion transistors. This thing has 40 times more, but the size itself doesn't matter unless you understand what it's actually built to do. This chip is purpose-built for training extremely large language models and running massive inference workloads. It's not designed for gaming. It's not designed for consumer applications. It's designed to be the foundation layer for national-scale AI infrastructure. The architecture is built around a distributed computing model. Instead of cramming everything onto one piece of silicon, the chip is organized to handle parallel processing across enormous datasets. The goal is simple: reduce the time it takes to train frontier AI models from months down to weeks or days, and do it efficiently enough that the energy costs don't bankrupt the operation. Here's the reality about AI training right now. To build a competitive frontier model, something that can compete with GPT-4, Claude, or Gemini, you need access to massive compute. Companies like OpenAI, Google, and Anthropic spend billions on GPUs from NVIDIA, which dominate the market. These GPUs work, but they weren't originally designed for AI. They were designed for graphics rendering. The AI industry basically hijacked them and optimized them as best as possible. That constraint matters. A chip purpose-built for AI training operates differently. It can be architected from the ground up to move data efficiently, reduce memory bottlenecks, and run the specific types of calculations that language models need. The UAE's chip, combined with Cerebras' software stack, is designed to do exactly that. What this means practically is that you can train larger models, train them faster, and do it on less power per calculation. For a country like the UAE, which doesn't have the history of semiconductor manufacturing that the US or Taiwan has, this is a way to leapfrog into the infrastructure game. The types of problems this chip can solve include training multimodal models that understand text, images, video, and audio at scale. It can handle long context models where you're working with millions of tokens instead of thousands. It can run inference at scale for national systems. Think government AI services, research infrastructure, or enterprise deployments where you need to process billions of requests without melting your infrastructure. This is fundamentally different from a GPU. A GPU is a general purpose accelerator. This is a specialized tool built for one job done at massive scale. Here's why the UAE is doing this. Right now, if you want to build advanced AI, you are essentially dependent on either the United States, which controls NVIDIA and most of the software stack, or China, which has its own chip ecosystem but faces export restrictions. The UAE wants a third option. It wants sovereign AI infrastructure. This isn't about competing on applications or chatbots. It's about competing on the foundation layer. If you control the chip, you control the speed at which AI develops in your region. You control the cost. You control who has access. You reduce foreign dependence. And you create an asset that other countries will eventually need to buy or lease from you. What the UAE is signaling here is that AI is becoming national infrastructure, the same way power grids, telecommunications, and transportation are. Countries that don't control their own compute layer will be at a disadvantage. They'll be waiting in line for access to American chips or negotiating with Chinese suppliers. The UAE is trying to avoid that position entirely. End of section. The UAE is not trying to compete on apps. It's competing on the foundation layer of AI. China currently has over 140 companies working on humanoid robots. That's not a typo, 140. And this isn't speculation or startups working in garages. These are companies backed by government funding, corporate investment, and deployment environments already being tested in factories, logistics hubs, and public-facing services. The scale of this is different from what the US or Europe is doing. In the US, you have a handful of well-funded companies like Figure AI, Boston Dynamics, or Tesla working on humanoid robots. They're moving slowly, testing carefully, building investor confidence. In China, it's happening in parallel across dozens of teams simultaneously. Some are competing, some are collaborating. Most have access to manufacturing infrastructure, supply chains, and real deployment sites that other companies would spend years trying to get. These robots are being tested for real work: warehouse operations, assembly lines, delivery logistics, hospitality, elder care facilities. They're not confined to research labs anymore. They're in production environments where companies are actually asking, can this robot do the job? Will it save money? What happens when it fails? This has nothing to do with ideology or Cold War thinking. It's about execution speed and practical resources. First, manufacturing scale. China produces the vast majority of electronics components. Globally, if you're building a humanoid robot with thousands of parts, motors, sensors, processors, power systems, you have suppliers already in the ecosystem. You don't need to build the supply chain from scratch. You can iterate fast. Second, hardware supply chains. If you need a custom motor, a specific sensor, or a specialized actuator, you can find factories that can produce it at scale. The feedback loop between design and manufacturing is tight. A new iteration that takes 6 months in the US can happen in 6 weeks in China because everything is closer together. Third, government backing. $26 billion in funding is a serious commitment. That's not just venture capital. That's state-level investment in a specific technological direction. It means that deployment environments get priority. A company working on logistics robots can get access to warehouses for testing. A company working on factory robots gets partnerships with manufacturers. The testing environment accelerates development. Fourth, fast iteration cycles. Because there's competition among 140 plus companies, but also a unified goal of advancing the technology, you see rapid experimentation. Designs that don't work get abandoned. Designs that work get copied and improved. It's messy, but it's fast. None of this is about being smarter or more innovative than the West. It's about resource allocation and execution speed. Here's what most people miss about humanoid form. It's not about looking cool or passing a visual test. It's about compatibility with existing infrastructure. A humanoid robot can walk through a door designed for humans. It can climb stairs. It can use tools and equipment built for human hands. It can work in environments where humans work without needing everything redesigned. Software only AI hits a hard wall without physical bodies. You can have the smartest language model in the world, but it can't move a box, assemble a component, or interact with the physical world without some mechanical system attached to it. Once you add a robot body to that AI, something changes. You've gone from intelligence only to intelligence with action. That's where the real economic value lives. When you combine a powerful AI system trained on those massive chips like the UAE is building with a humanoid robot body that can work in physical environments, you get something different. You get a machine that can do economically valuable work without constant human supervision. That's the business model that scales. Not surveillance, not entertainment, real labor substitution. The humanoid form matters because it sits at the intersection of two things: advanced AI and existing human environments. That's where deployment happens fastest. This is where it gets clear. The UAE is building the brains. China is building the bodies. The UAE's chip is purpose-built to train and run massive AI models efficiently. It's the compute foundation, but a powerful AI model running on a server doesn't do anything by itself. It responds to prompts. It generates text. It's useful, but it's constrained. China's 140 plus robotics companies are building physical systems that can act in the world, but those robots need intelligence. They need perception, reasoning, decision-making. A robot without good AI is just an expensive machine that does exactly what you programmed it to do, nothing more. When you combine them, when you have sovereign compute infrastructure powering intelligent robots deployed at scale, that's when you have real leverage. That's when the economics flip. The next AI race isn't about who builds the smartest chatbot. It's not about who has the best API or the best consumer application. It's about who controls intelligent machines in the real world, who can deploy them at scale, who can make them work reliably in factories, logistics, construction, healthcare, and everywhere else there's physical labor. The UAE is saying, we control the infrastructure. China is saying, we control the deployment, and the country or coalition that controls both wins. So here's where we are. The UAE just showed it can build frontier-level AI compute infrastructure independently. China is actively deploying hundreds of humanoid robots into real work environments with massive backing. These aren't separate tech trends. They're two pieces of the same shift. The real question now isn't who builds the smartest AI. It's who can deploy it at scale in the physical world. And right now, that answer is becoming clearer by the day. If you want clear breakdowns of where AI and robotics are actually heading, not hype, just the facts, subscribe. Drop your take in the comments on where you think this goes next. Thanks for watching. Catch you in the next one.